Hello, everybody, and welcome to the session. We're going to get started here in just a minute or two, give some people some time to jump over on this call. But we'll be right back. I'm real excited to talk to Form3 today. So be back in just about a minute or so. Thank you so much. All right. Hello, everybody, and thanks for joining us today. Excited about this session. I'm going to say good morning from here in New York City. It's just getting light here, but I'm excited to have somebody across the pond, my friend Kevin, join me today here to talk about what they're doing at Form3. So good morning, good evening, good afternoon, wherever you're at in the world, everybody. Thanks for joining us today. So, real quick before we get started. We would love questions from you. This is hopefully an interactive session. What Kevin and team has done at Form3 is truly phenomenal. I mean, it's work that I've never seen before. Once I saw what was possible with Cockroach database and the way they think about cloud providers, I thought it was pretty tremendous. And I had a whole lot of questions when I first met Kevin about the implementation and some of the details. So, y'all please do ask questions in the chat, the QA. I'll monitor that as we go along. And then, of course, the recording will be available a little bit later today. We get it up pretty soon into our in our public YouTube channel. So, so all that stuff is all good. Yeah. So Kevin, I'm going to say good morning. I keep saying good morning to you, but I know it's afternoon. But welcome. How are you today?
Hi, Jim. Yeah, I'm really good. Thank you. How's it going?
I'm doing very well, Kevin. So, Kevin, do you want to just give a quick introduction in terms of, what your company is, what your role is at Form3? I know we've talked about a fair amount, just so everybody kind of gets a better sense.
Yeah, sure. So, my name's Kevin Holditch. I'm basically head of platform engineering at Form3. So basically my role is to look after the kind of technical direction of the platform. And I head up, I think it's about 6 or 7 engineering sub teams now who work on sort of different parts of our platform. So that's across the board in terms of a couple of teams working on Multicloud, which I think we're going to discuss in more detail. We have various other teams looking after different aspects of our platform, such as we actually run a couple of data centers and virtualized infrastructure over there. So kind of the role cross cuts all of the platform, basically.
Yeah, and you have basically you mentioned something that was kind of interesting. You're using both public cloud and your own data centers. Is that correct, Kevin?
Yeah, that's right. So I think that's basically to support a project called FPS, which I think we also use Cockroach for, and we can touch upon that, I guess, later in the show. So we've got quite an interesting design going on there. Yeah. But I guess the key point about how we're treating our data centers is we're treating them as our own sort of private cloud. So we're using technologies such as Cloud Stack So we can sort of virtualize all of that infrastructure, and then to the engineers using it, they can use the same infrastructure as code tooling, such as Terraform, to create all of their Kubernetes clusters and everything they need to do on top of our infrastructure. So even though we manage it, the experience to the engineers is the same between the cloud and our own data centers.
Yeah, it's rare that I run into people running their own data centers anymore, Kevin. I was just going to say,
Yeah,
it's one of those things, right?
We wouldn't choose to do it, but I guess that's part of our offering. So to connect to some of the payment schemes, you actually need physical lines into the schemes, and to run certain equipment such as HSMs, and they mandate that you have to have a physical data center present. So it's unfortunately it's unavoidable for us, but we try and make it the best experience as we can.
Well, and that's what I mean, Kevin. So talk to me a little bit about the business, right? Because I think there's business requirements that are going on here, right? And the sector in which you play has very kind of unique requirements that do require me to have like that sort of thing. It's kind of where I was going with it, So can you just describe, the market you play in and what Form3's role is within that space?
Yeah, totally. So what Form3 basically do is we solve a problem that banks and regulated financial institutions have. And that problem is access to payment schemes. So maybe just to set the scene, what a payment scheme is basically a solution. So if, say, Jim, you bank with Bank A and I bank with Bank B, and let's just say, to keep things simple, those banks are in the same region that share the same currency. The banks have a problem in how do they move the money from Jim, your bank account, to my bank account with the other banks. So to make that happen, there's a few kind of high level things that need to sort of take place. So one is your bank needs to send my bank a message saying, hey, Jim wants to send Kevin £10. Do you know about Kevin? These are his account details. My bank need a way to reply and go, yeah, that's cool. We know about who Kevin is. And then they need a way to basically reconcile the money. So actually physically move the money from one bank to another. Mm-hmm. So we're not going to go into all the mechanics of how that works. But the problem that banks have is, even though that's sort of a simple problem and the solution to that is a payment scheme, there are many, many incarnations of payment schemes. So in the UK, the two typical ones that most banks use is FPS, which is real-time, a payment system. And then there's BACS, which is like a intraday. It takes 3 days for payments to go through. And then moving into Europe, you've got sort of 3 main payment schemes, which is SEPA Instant, which is real-time in Europe. And you've got SEPA Credit Transfer, which is intraday payments in Europe, and then you've got SEPA DD, which is a way of collecting money similar to what you can do in BACS. So even though all those payment schemes I've just spoken about all solve that basic problem of allowing Jim to send Kevin £10, unfortunately, the implementation is completely different. So that is like, how do you connect to that payment scheme? Do you have to have a physical like lease line connection? Can you connect over the internet? Is it a VPN? How do you, what message format do they use? Is it XML? Is it JSON? Are they using like fixed file width formats? How do the flows work? How do you handle errors, et cetera, et cetera? The list goes on and on and on. And on top of all of that, these payment schemes actually make changes every year called like maintenance changes. So they'll add new flows, they'll deprecate fields, et cetera. And as a member, you have to stay on top of all of that. So if you are a bank, which is in the UK or Europe, commonly you'd want to be connected into those 5 payment schemes I've just mentioned. So just say you wanted to start a bank, that's 5 integrations you've got to do. Some of them will require physical data centers, a lot of engineering effort just to enable your customers to send and receive money to all of the places they would expect to be able to. And then you've also taken on yearly maintenance upgrades on all those 5 payment schemes, which is a hell of a lot of work when really you just want to enable your customers to send and receive money. So what the Form3 business proposition is, we are a single cloud-based API that basically downstream we're integrated into all the payment schemes. And then our customers can integrate with us once, and then they get all of those payment schemes from a single integration. So we can take a customer's route to market from typically a year per payment scheme to build all of that stuff themselves. We've seen customers go live with Form3 in like 8 to 10 weeks. So we can take customers live very quickly, which is a massive benefit to them. And they no longer have to worry about any of that stuff because it's all hidden behind our API. And I think the the real sort of beauty in how we've done it is we've found a way to abstract away the differences between the payment schemes behind our API. So for example, whereas before the customer had to worry about all the different fields for the different schemes to basically represent, let's say, a payment, now they can create a payment resource in our API, which is a JSON document that is very easy to understand. And then one of the fields might be, I want to send that over BACS. So they'd create that resource, and then downstream we'd go, oh, you want to send that over BACS? We'd route it to BACS, which would require like generating this archaic 1970s format, batching it up, sending it off, getting the response, and then we asynchronously would tell our customer if it's succeeded or not, which is all they need to worry about because they need to either book the payment or not. And then the beauty is they could create that same resource, but then change that one field from BACS to say FPS, and then we'd route it over a real-time payment system. But the experience for the customer is exactly the same regardless of the payment scheme.
Yeah. It just seems like one of these kind of archaic processes that never had any sort of standardization that is a pain in the rear for basically everybody, right? I mean, it's not just like the get up and running in 8 to 10 weeks, Kevin. It's the ongoing maintenance of these things as well require teams of people, I presume, right? I mean, as you know, that's a difficult proposition. I've been through that, right?
Yeah, totally. So that's what inhibits kind of some of these mobile banks getting to market very quickly, which is one of the problems that Form3 solves, because you suddenly need this team of engineers, like in the case of FPS, you might have to have physical connections to the scheme. You have to have your own equipment in data centers, all the rest of it. When, like you're saying, the fundamental problem is you just want to send and receive money. You don't want to worry about any of this stuff.
Yeah. So are you saying some of them actually require like certain physical kind of connections? Like, I mean, it's all the way down to it's not just formats, it's physical, like hardware too, right? Like that's crazy, man.
Yeah, that's so FPS in the UK require that. So you need a physical connection in. There are kind of ways you can get around that. There are some products that enable you to like use someone else's gateway, but you're really you still got the problem with different message formats between the different payment schemes. So it's quite a tough what do you call it? So quite a tough integration for someone to do themselves.
Yeah. Well, it's a complex integration, right, Kevin? And so there's got to be some pretty unique requirements around it. I mean, you know, it's money, so it can't fail. Number one, I'm going to presume, right? Like, you know, what are some of the, I mean, there's got to be some really stringent requirements. What are some of the key things that you had to focus on in terms of, you know, architecting the system, make it right?
So I think, so when we started, it was a startup that's absolutely exploded. So what we did to begin with was we just concentrated on leveraging the cloud as much as humanly possible, because we're a small team and there was a lot that we could let the cloud vendor handle. So the first version of our platform, we leveraged AWS for all of that. So we used technologies such as SQS to handle the workflow of a payment. So we'd send messages on SQS, let AWS worry about the durability of those messages and not losing them, which all guarantees they can give you. We went with Postgres for data storage, because as you can imagine, for a payment, we need to make sure that uniqueness is everything and data consistency is everything. So we used RDS hosted on AWS for that. And that worked really well for us. That enabled us to get to market quickly and to grow the business. And we were super successful with that. But one of the trends we're seeing in the industry, and we've seen this gather momentum over the last 2 years, is I guess the banking and the banking kind of sector is one of the last sectors to move to the public cloud. A lot of banks are still running in their own data centers. And the regulator, and in the UK, the Bank of England, are getting quite nervous about lots of banks all choosing the same cloud vendor and what the exit strategy is for that. So because it could have sort of really bad consequences for like the UK economy, in the UK's example, if that cloud vendor did something bad, withdrew themselves from the region, double their prices, or one of those events. So the regulator is kind of pushing that requirement onto banks and onto Form3 and saying, well, you need to tell us what would happen. like in Form3's case, if you couldn't use AWS anymore, what would be your strategy? And we were kind of snookered at that point because we'd built our platform and intertwined it with all of AWS's technology. So our solution to that was to sort of take a step back and think, well, how can we make our solution more portable and be able to run in more places? So one approach we could have taken was taken all of our platform and re-implemented it against one of the other cloud providers, such as Google. So instead of SQS, use their pub sub. Instead of Postgres and RDS, use Google's version, etc. But the problem with that is now we've got two versions of our platform that would have different behavior. It'd be very hard to keep that behavior the same, debug issues, and all the rest of it. And we just thought, I mean, that is a strategy, but we just thought that would be sort of fairly tough to do. So then we thought, what would actually be nicer is if we could just not depend on any cloud vendor. So run across multiple cloud vendors in real time, so that theoretically we could sort of say to regulator, hey, if we don't like AWS for whatever reason, we could turn them off. So I think that's the discussion we're going to get into, but and Cockroach became a key technology choice into sort of enabling that.
Yeah, so Kevin, I definitely want to talk about Cockroach, but I actually want to ask a little bit about that decision, because I totally understand. I mean, basically you're trying to mitigate risk and complexity anyway. So you were trying to basically take, a lot of different payment systems and eliminate that risk for your customers. I mean, geez, you were going to have to actually do that for your own implementation, right? It would have been two completely different systems, and that would have been a nightmare. But to make the jump from, one set of cloud providers tools to another cloud providers, cloud provider set of tools, that's one approach you could have done. To just go, truly like intercloud, multi-cloud, where you're actually running across, you're treating the cloud providers as infrastructure. That's a big leap, Kevin. That's a big leap. I think most people have an intermediate step there where they're saying, maybe I have the same stack of technologies, maybe it's open source, maybe, whatever it is, running in each cloud providers, and I could just stamp it out so it's kind of the same. Did you guys go through that process, or did you guys just jump right to this kind of bigger picture, mitigated across multiple cloud providers?
No, we're just jumping straight to the bigger picture. And I suppose our intermediary step is our FPS gateway. So the FPS gateway that we built to serve UK FPS traffic, the architecture for that is we have a Kubernetes cluster in a physical data center. We have another Kubernetes cluster in another data center and another Kubernetes cluster in AWS. And those are all privately networked together. And we also run Cockroach across that. So we had sort of familiarization with this architecture, if you like. And then because we've run that system in production for coming on for a year, we've got a lot of confidence in how that technology all plays together, and we can dig into some of the components. So what we basically thought was, okay, we can lift that. So rather than being AWS data center, why not just make it AWS, GCP, Azure? Because really, all we need the cloud vendors for is to run a Kubernetes cluster in this case. And then we're going to leverage like the same primitives in Kubernetes in each cloud vendor. So we're not going to take any dependencies out on anything that's different. So as far as the software is concerned, it doesn't even know what cloud vendor it's running in. It's just running in a Kubernetes cluster somewhere that happens to be AWS, happens to be Google, happens to be Azure. So then I guess to make that work, we had to privately network all of the clouds together. And how we could do that is we've already got two data centers. So the basic architecture for that is we have dual direct connect lines. Each cloud vendor names it differently, but I always use like the AWS terminology. So it's basically like a connection from the cloud to our data center for each cloud vendor, multiple times for high availability. And effectively what we've got in simplistic terms is a router in both data center to say, and then we set wide network ranges up. So we say, if the network range is in this wide CIDR block, send the traffic to AWS. If it's in this CIDR block, send it to Azure. If it's in this CIDR block, send it to GCP. And then that kind of network layout gives you connectivity between the 3 Kubernetes clusters. So that's really like the building blocks that all of this is built upon.
Yeah. By the way, first of all, congratulations. You're one of the few people who actually solved the networking problem between multiple Kubernetes clusters. It's an extremely complex problem, right? I think there's been a lot of organizations trying to sort that out, Kevin, and it's not simple. But let's come to that. I would love to come back to that actually, because I'm curious and interested in that kind of stuff too. And I know you're working with, I think you're working with Isovalent and the Cilium team on that side. I don't want to get too deep into that. I'm personally curious on those things. I think because, when I first got involved with Kubernetes, this whole kind of concept of actually, mitigating compute across multiple different clusters, or there was a SIG federation, which was basically, there was a special interest group in the Kubernetes community about how do we, federate clusters and get one sign a single control plane. And it never really got anywhere because it was so complex. Mm-hmm. When I saw Cockroach, I kind of was like, well, why deal with that? Maybe if I manage 2 clusters, but I can maybe federate at the data layer. That was the thing about Cockroach that really, I couldn't unsee that, honestly. I just really couldn't. And I think it's kind of one of these natural things. And to see somebody doing this sort of thing live is really, really kind of phenomenal, honestly. So, but I want to talk about that.
Just on that, I think you've hit the nail on the head there, because I think federating clusters together, if you got to that's a nightmare, because if you got to the point where one cluster going down affects the others, that's definitely what you don't want. So what's nice about this design is each cluster and each cloud vendor is completely isolated. They barely know about each other than there's a Cockroach node on one of the other clusters and there's a route between them. And we can talk about a little bit about how that works. But so it gives you that, like, the best of both worlds, if you like. You've got an independent cluster running, and if one goes down, it won't take the others down with it, which is
right. And that isolation to actually avoid and mitigate the risk is, I think, something that people don't think about a whole lot, Kevin, because it's kind of really difficult. Like, it's kind of one of those things like, okay, great, maybe I can't run the database. So y'all were using Postgres at the beginning, and I presume I know, I'm sorry, you migrated to CockroachDB eventually. Mm-hmm. What was the decision around that, Kevin? Kind of what went into that choice, right? Because it's not an easy. Look, migration of a database from anything to anything is not simple. Like, it's never simple. So it's a big choice. And so what went into that consideration?
So basically, the main considerations that we had was, one, we needed a database that we could run on any cloud provider. So although each cloud vendor have databases that are highly scalable, such as AWS have Aurora, and I think Google have Spanner, that wouldn't solve Form3's problem, because we're trying to mitigate against cloud vendor lock-in. So we needed something that really we could run ourselves, because that's the only way that we could mitigate that risk. We also wanted something that would be easy to run, and the other key driver is we needed something that put consistency first. So I guess at a high level, there's sort of 2 main types of databases you can go for, like AP databases or CP databases. So roughly speaking, if you have like an AP database, it's guaranteed to be very available and horizontally scalable. This is something like, I guess, Cassandra, or one of those technologies that might give you really good read performance, so you don't mind about a bit of latency. But the problem is your data is not guaranteed to be consistent. So any node might have a slightly different view of the world, which is obviously not suitable for Form3's use case, where we need to guarantee that we don't duplicate someone's payment, because then we're inventing money. So whereas Cockroach really hits that sweet spot between the best parts of a relational database, which is the ACID compliance and being CP and write consistent, and it gives you the horizontal scalability of something like Cassandra or one of the NoSQL databases, where you can add more nodes if you need more sort of scalability, which is, I think it's pretty much one of the only products in the market that really solves that problem. And that, coupled with the fact that it's super easy to run in Kubernetes, it's pretty much a very straightforward deployment. It's obviously a bit more complex when you're running it multi-cluster, but it's still not, unachievable. So yeah, I think obviously the key point being horizontally scalable and having that right consistency. So we're guaranteed that we don't lose any payments. And I think because you can also configure Cockroach in a number of different topologies, so you can actually say, I've got customers who only live in this region, so I want all their data over in that region, which would give you better performance in that region. But the trade-off being, if that region goes down, that data's gone. Whereas the topology that we've gone for is, we've sort of told Cockroach about our click-free cloud providers, and it can guarantee that there'll be a copy of data in each cloud provider. So that really meets our overarching requirement that you could switch any off and we haven't lost any data. So you could switch the whole of Google off and we're guaranteed to still have a copy in AWS and a copy in Azure, and we can carry on writing.
There is a whole lot to unpack there, Kevin. I was taking a couple of different notes. And it's basically, I guess it's the story of my life right now. It's like this world I live in, right? I kind of live and breathe this stuff. I actually wake up dreaming about certain things in Cockroach sometimes. It's kind of I don't know if it's a nightmare or it's a dream. I don't know. It's great. You hit on a couple things, and I think one of these things is like, yeah, you wanted to run itself. You didn't want to rely on a service that was from a particular cloud provider, which is like we hear that a lot. Like, I think it's real easy to spin up a service and maybe use those services in the context of whatever you need to do, but you use this along with it. And I think that's kind of one of those things that freedom to run it anywhere, the freedom to make that choice and to kind of go through that is it's such a big deal, I think, for many organizations. But I wanted to come back to like that. I just want to highlight that, number one. But like, I wanted to come back to, you were talking about CP versus AP databases, and I'm not sure if everybody understands. It's the CAP theorem is what I think Kevin is referring to. If you're not interested, or if you haven't heard of the CAP theorem, y'all, we ran a webinar on that one as well. You go look it up on Wikipedia. The Wikipedia entry is actually pretty good on it, right? So, but in the context of that, Kevin, I did want to actually drill into one thing when you talked about CP versus AP databases, right? An AP database, yeah, it's going to guarantee availability, even in the event of a partition tolerance or something going down. You're going to have availability across all the nodes. CP is, you're going to guarantee consistency. Now, one of the conversations I get into people is like, look, it isn't like it's not binary. It's not like there's a CP and an AP, right? Like there's a range of availability in the context of this consistency as well, right? And so, because I presume availability is a big requirement for Form3, and we're talking about payments, right? So how do you guys mitigate that as an issue within the context of Cockroach? Because I think it's a concern, I think, for people, right?
Yeah, it is. But I guess the way that you're guaranteeing availability is that you're running several nodes in each cloud. So to not be able to do a write, I think in Form3's case, it would mean that 2 of the 3 cloud vendors would have to be offline. So the nodes in the 2 other clouds would have to be offline, which obviously could happen, but it's probably highly unlikely. So like you said, it would have to have multiple network failures between one node. One node would have to be completely isolated away from the others. And even in that case, I believe you can still do reads for a certain amount of time.
I think that availability thing, I always feel like comes back to, what is your failure domain? And that can be, do you all think about that in terms of a multi-region and where data gets placed, Kevin? Do you think about it just basically generally as the whole database, is across the 3, or is it table by table? Are you guys granular in terms of how you're thinking about the data?
No, so we are basically just running the whole database across the 3, because I suppose, like I sort of mentioned a few times, the overarching goal here is to be able to technically switch off any cloud vendor. And we're knowing actually we're sacrificing a tiny bit of throughput for that, because to do a write, Cockroach now has to communicate, say the write is happening on GCP, might have to communicate with AWS, which is actually, the latency is actually fairly good between the 2. Let's just say 4 to 5 milliseconds, but that's got to happen. Whereas if we said to Cockroach, actually, you can put all of GCP's data in GCP, that write would be much faster because it wouldn't have to leave that cloud. But like we're saying, then if that cloud vendor went down, that data is gone. or until it comes back again. So I think we're happy with that trade-off, because like I said, the main driver here is having that availability and resilience against a cloud vendor. So.
Yeah, the failure domain becomes the cloud provider, as opposed to, like, I think people think about an availability zone. An AZ is typically like the failure domain that people think about. How many places are you running in Europe today, Kevin? Is it just in the UK, or is it across Europe?
No, so we have a couple of instances of our platform. We have one in Europe, which is actually running in Ireland, and we have a couple running in London. So customers, when they onboard, they can typically choose which platform they want to come onto, which some customers have requirements. They want to keep their data in Europe, obviously with the whole Brexit thing now. So we can onboard them onto sort of whatever platform fits their needs best.
Yeah. And then you also mentioned something when we were talking about requirements. You said, you wanted something that was easy to run. Mm-hmm. Sometimes when I think about Cockroach and like how you set up the schema and how you think about multi-region, there's some complexities in a distributed database that are not normal to a normal relational database. And I think people but you had mentioned something about it being easy to run. Can you just dive into that a little bit, Kevin? Like, what you meant by that?
Yeah. So basically with Cockroach, it comes with sort of Helm charts that are sort of fairly easy to install. Say you just wanted to install Cockroach on a single Kubernetes cluster. I would sort of say anyone who's sort of familiar with Kubernetes would be able to, that would be a fairly simple operation for someone, because they can literally just install it into the cluster and it will just be sitting there running, like done. So I think you guys have done a really good job of sort of packaging up Cockroach and sort of making it an easy install. And also I guess part of the cool thing with Cockroach that we haven't touched on yet is that it's Postgres dialect compatible, which is another reason that it was a really good choice of Form3, because as I mentioned earlier, we were previously using Postgres. Yeah. So this enabled a sort of fairly easy migration for us, because a lot of our sort of queries and data structures just worked on Cockroach with minimal work. I think there's a couple of queries that we had to tweak slightly, but that was like few and far between. So most apps we can almost just drop across to Cockroach, and we're still doing that migration. But that's fairly easy. But the other thing that the Postgres compatible dialect gives you is a lot of the tools that people are already familiar with will also work on Cockroach. So you can basically, see what the database is doing, and use that same sort of tool chain.
Yeah, that wire compatibility was a really important choice early on for Cockroach. I think Peter Mattis, one of our founders, helped make that decision. It caused a lot of work, because implementing the SQL syntax of Postgres is not simple. No. We had to redo it and re-architect it, right? So it is distributed. And I think, the distributed nature of the database does cause, I think it's a little bit of a paradigm shift for developers sometimes, but it can be very straightforward. And Kevin, I know you kind of are more in the platform group, so I'm going to ask a little bit of an odd question. The developers that actually interact with Cockroach, is it just like Postgres for them, or do you hear any kind of like pushback on this? Is it fairly straightforward for them?
So most of the Form3 platform is written in Go. And so far, from when I speak to the application engineers, they've had a fairly seamless experience integrating with Cockroach, because there's already sort of Postgres sort of drivers for Go, and they just work sort of out of the box with Cockroach. And we've done some, so all of Form3 software, we test it end to end using Docker containers to simulate infrastructure. So for example, we have like an application that might use a Postgres database. What we do is we spin up that Postgres database in a Docker container and run end-to-end tests against it. So we've actually done quite a few tests where we go, oh, how hard would it be to migrate this application to Cockroach, which is a matter of swapping out that Docker container for a Cockroach database and seeing how many of those tests pass. So it gives us a really quick way to get feedback on that. And I think, like I was saying earlier, we found that it's quite highly compatible with a lot of our software, and it might take a little bit of tweaking, because we do some quite advanced things with sort of JSON-B structures, which I think recently is much better supported in Cockroach, but maybe like 12 months ago, there were a few tweaks there. But yeah, I think you guys have done a pretty good job on the compatibility front.
Yeah. Well, like I said, it wasn't simple to do, but you bring us to kind of our next point I wanted to ask about. And I think Cockroach, for kind of the main workload, the requirements around consistency, of course, a big deal. Scaling that business and making sure that you have enough bandwidth and throughput through the database, and it's not going to hold you back, is a big deal. The multi-location and multi-region, and region being cloud provider, I think is truly, Kevin, phenomenal. And if we have time at the end, I did want to come back to some of those kind of nuances as well. But what else are you looking to use Cockroach for? I mean, if you just spin up this other Docker container Cockroach cluster and point it at these other workloads, what else are you looking to use Cockroach for?
Well, the other product we've got in production that we're using Cockroach for is our FPS gateway, like I mentioned. And the reason for that is initially we looked at using Redis to store this information. So in our FPS gateway, remember the architecture for that is 3 Kubernetes clusters, 1 in each data center and 1 in the cloud, connected together. And basically we need, like, it's almost like a working memory when you're working on payments. So for FPS, there's like a recent history, let's say, window that you need, and you need to know about all of the bank accounts that your customers have, because basically when a payment comes in from the scheme, you need to match it against their account list and then quickly reply. So to fulfill those requirements, we needed like a hot cache, if you like, to store that data. So we went for a few incarnations of what to use for that, and then we ended up landing on Cockroach as the best solution for that, because again, it fulfills those requirements of we've got consistent storage, and we could run it across each of those Kubernetes clusters like a single database, and it just worked really well for that problem. And I think, like we kind of touched on, the performance of Cockroach, even though it's doing some amazing gymnastics under the bonnet, like to what you think is just a simple query, it's actually going off to different nodes based on where the data is actually physically stored to retrieve it. The performance is actually really good that we've observed. So I think it almost feels a little bit magic, if you like, that it almost gives you like the best of both worlds. You've got this scalability and you've got this really good performance.
Yeah, I think it's we have this conversation internally a fair amount about this sort of stuff, Kevin. It's like kind of one of these things where it's one of the most difficult software engineering problems there is on the planet is, how do you make a database that is going to be consistent yet globally scalable? We're dealing with the speed of light, you know what I mean? And I think it's not many people realize, I'm actually going to be talking to one of our engineering managers later today about, what do we do to actually, combat the speed of light, because we're dealing with physical limits of infrastructure today. And I think, what you all are doing are dealing with, the physical limits that the cloud providers put on you. And I think I put on all of us. It's funny, we build Cockroach Cloud, or CockroachDB Cloud, our own version of Cockroach where we deploy it. We have an AWS version, we have it in GCP, we're building the Azure stuff. And like building Cockroach was a challenge, but like actually building these things for these different environments was a wholly other challenge. I don't know if people understand the complexity and the differences across the cloud providers. I think those are, to me, are two of the biggest challenges I think that many people have. And to see y'all kind of like address the multi-cloud side of it, Kevin, it's truly tremendous. So going cloud native is one thing. Go on. Sorry, go on, please.
I was going to say, yeah, it's definitely not to be underestimated, like the challenges you have with the cloud providers. So I could mention a couple of different points here. One is, one of the decisions we took was to use each cloud vendor's managed Kubernetes offering. So there's a decision point there on how do you run Kubernetes? Do you basically just use VMs off of the cloud provider and have bare metals clusters? So that would have the advantage that you had the same experience in each cloud vendor, but that has a disadvantage that now you need an army, I would say, of Kubernetes experts to keep that running, because Kubernetes is fairly tricky software to manage, maintain, and upgrade and run at scale, type of scale we need it to. And so we took the decision, which I think is proven to be quite a good one, to use the managed control plane offering from each cloud vendor. So you basically let the cloud vendor run Kubernetes, look after the control plane. And then the good thing there is we can get our engineers just concentrating on the value add for Form3, which is obviously running our software and getting like Cockroach, as we're discussing today, like configured on top of that. And then the good part there is if the Kubernetes cluster goes down, we've got enterprise support with the cloud vendor, so we can go and beat them up if it's not running. So we've got, you know, someone on the end of the phone who's responsible for that. And what I'm actually finding is that is actually working remarkably well, because the cloud, what was I going to say, Kubernetes is getting sort of fairly mature in a lot of these clouds. So not having the obstacles of running it yourself is a really big win. So I think it's not to be underestimated, because if you ask engineers, they probably go, oh, I want to run Kubernetes myself because, you know, that's the enjoyable thing to do. So yeah, but even in doing that, so what I was trying to say is, I think what people should try and focus on is pushing as much responsibility to the cloud vendor as humanly possible, but without any vendor lock-in. So that's where the kind of managed offering for Kubernetes is the real sweet spot here. So you're kind of letting them run the control plane in each cloud vendor, but below the bonnet at the pod level, it's still Kubernetes. Like the pods don't really know or care, or the workload, should we say, don't really know or care what cloud vendor they're in. So that's where I feel like it's quite a nice balance we've got.
Yeah, I mean, it should be the same across the cloud providers, but it's funny enough, it's often not when it comes to the various different services and tools. Kubernetes is very, quite different, right? Because I mean, I think it is kind of standardized. I think there's nuances between versions, but they're less and less these days. Is what I'm finding, right? And it's like, if you look at GKE versus EKS versus Anthos versus all of them, they're getting to be somewhat. I just think that Kubernetes becomes kind of commodity after a while, Kevin, and it's a commodity level. Yeah.
One of the things you have got to be wary of, like you said, is the one thing you are sacrificing is the cloud vendor is in control of when they release the version of Kubernetes. So you have to be careful around matching versions often, or taking dependencies out on bleeding edge Kubernetes versions, because that might be available in Google before it's available in AWS, as an example. So you have to be careful about that. But I think as long as you're aware of those considerations, then you should be fine. And it's much simpler than trying to run the clusters yourself.
Yeah. I mean, I enjoy engineers that want to go out and run Kubernetes, just go become an SRE and go do it for somebody else, because why do we need to do these sort of things? Like, that was the whole point of the cloud providers in the first place, is just run all that stuff. Like, just let it go. It's, Kevin, I was at CoreOS, early days of CoreOS as kind of the Kubernetes thing was emerging. And, we were trying to build out Tectonic, which was basically like, oh, how do you do this very simply? And it was like, it was right. It's just that I think I think in today's world, you want somebody else to manage that stuff. There's no competitive advantage in managing it, right? I mean, the competitive advantage is in your business logic and what you're trying to accomplish, right? And I think that's such a big deal. Go on. Sorry.
I was going to say exactly. So I think that is where what sort of my teams are really trying to do. So make that experience to the engineers at Form3 who are writing the business software, that they don't really need to care about what cloud vendor their software is running in. So to make that happen, we provide like a Kubernetes cluster and a Cockroach database for storage. We're also using a technology called NATS for messaging, which is basically replacing SQS and SNS in AWS. So all that they need to depend on is those technologies, and then they don't need to care about what cloud their container's running in.
Yeah, and that's the way it should work, actually. So, if anybody has any questions, please do. I have one question I would love to ask Kevin, and it's one of these things that I'm acutely interested in. But if anybody else has any questions, please do throw them in the chat or the QA. I'm happy to throw them to Kevin. Networking across clusters, it's not simple. This is kind of one of those things we talk about, networking and security is kind of one of these two big challenges as you're running multiple Kubernetes clusters. What are you guys doing to solve the networking issue?
Yeah, that is probably a whole other webinar in its own right.
Yeah, I know.
But I think probably I could go through a short version that would get someone going on the cloud. So basically what you can do now, which is really cool in each cloud vendor, is they enable something called, I'll just kind of call it native routing. So basically this is in AWS, the basic building block is like a VPC, which you give like a network side range to. Now, what you can actually do now is you can say in your Kubernetes cluster, I want the pods to have IP addresses in my VPC side range. And this is something that every cloud actually offers now. So whereas I guess in sort of typical Kubernetes clusters, if you run it yourself, you'll typically have a different virtual network for your pods in like an overlay network. And the problem with that is it's hard to make that routable outside of the cluster because only that Kubernetes cluster knows about that virtual pod network. But if you use this native routing construct that I just explained in each cloud vendor, then the basics of it is if you can network them, and there's lots of ifs here, and I'm not saying it's simple, but if you network all of the clouds together and then set up routes between them, so you say, this packet's headed for the VPC in AWS, you send it to the VPC in AWS, this packet's headed for the VPC in GCP, send it that way, etc. Then basically, once you've got all of that set up, a pod in this cluster, as long as there's no sort of firewalls blocking it, could talk to a pod in any other cluster because they're all in the sort of top level VPCs, if that makes sense. So that would be like the easiest possible way you could solve that problem. And once you have that, then it would be a matter of pointing, you could run a Cockroach node in each cluster if you wanted to run your Cockroach database across, and then point the Cockroach nodes at each other to form the cluster.
Yeah, it sounds so simple.
Yeah, it's really not.
It's really not.
No,
it really isn't. It's kind of one of those things that what can go wrong will. We learned a lot building Cockroach, and it's like what can go wrong will. And I think it's a pretty phenomenal. These are tough challenges, I guess. So, so let me see. There's so there is a question here. So, what lessons would you give as advice to somebody that's moving from Postgres to CockroachDB? How do you start the journey? How do you move as quick as possible? What are some of the best practices of moving from legacy to Cockroach?
So that's a really good question. So I think the way Form3 have approached it is, as I mentioned, I think a really key part to this is having a really fantastic test suite. So this is something I'm very passionate about. If your software can actually test end to end as much as humanly possible, including the database, then those tests are going to be so much more valuable than if you choose to like mock out your database. Like personally, I'm pretty against mocking unless it's a very extreme sort of situation. So because we built our tests in that way, as I sort of explained earlier, that gave us a really easy mechanism to have full confidence that our software would work fully with Cockroach, because we could run all of our test suites that we already had against Postgres and run the same set of test suites fairly easily against Cockroach, which exercise all of our payment journeys. And then from there, it's a matter of restoring the data, as I kind of touched upon earlier, because it's like wire compatible, you can actually restore the data into Cockroach. And then you need to manage sort of the cutover. So there's sort of various techniques of doing that, and it really can depend on your use case. But I suppose that the key point I would sort of drive at is really having a fantastic test suite that exercises your software end to end with the database, which is fairly easy to do today with Docker.
Right. Yeah, it's one of these things. It's funny, like, Kevin, I come across teams that are doing this, and it's like typically teams, when I hear they're coding in Go, I'm like, okay, this is going to be a little bit easier. You know what I mean? I think that using these threaded languages, having developers kind of get this distributed mindset, that sort of stuff, it does help, because I think there's things like try catch blocks that actually have to be put in place sometimes, because you're going to get you're going to get transaction retries with Cockroach. It does happen because of the nature of the database and what it's doing underneath the covers. It's one of those things, once you get used to it, it's like, oh yeah, I see why. And it's super valuable. Well, I mean, I think for your use case though, like the consistency was driving people to be fairly good programmers as well, right?
Exactly, but we'd rather know about that. So if I
Yeah,
can't write a record, I want, as a developer, I want to know that's failed, and then I can handle
that's
that
right.
in my application. I don't want the database to be in some inconsistent state and me just to carry on with my work and then have, who knows, hell, break loose later on because the data is not written correctly. So
Right.
I think,
Like you lost somebody's money at that point, Kevin.
exactly.
Like you
So we would
literally have
rather
like
that,
lost money.
yeah, exactly. So
Yeah.
we just rather fail at the earliest point when we try and write the row and go, okay, we can't write that for whatever reason. Even if that means returning an error back to our user and saying, error, can't process this payment, can't create this payment. That's better than having inconsistency. So that's a trade-off we're willing to make.
Yeah. I think that's just one of those things that people get used to when they start dealing with the database that's like this as well, because these things are going to happen. And it's actually, I think it forces good hygiene in code. And I'm with you. You should want to know when these things happen.
Exactly.
And architect them out of the system, I think is what, elegant code is all about. Right. So I think
And
that's,
getting back to what I was speaking about with testing, we actually test for those scenarios. So what we do is, as I just spoke about, we have our application run against a Docker container, say with Cockroach in. Another cool trick is we use Toxi Proxy, which is like an open source proxy. So we'll route the connections to Cockroach through a proxy. And then what we can do is we can turn the database on and off. So we can start a payment and then we can say, given the connection to the database goes down, and we can just drop the connection in our proxy, and then we can make sure our software handles that failure correctly, or we can add latency and we can do loads of cool stuff. So we can make sure we're resilient to all the types of failures we'd expect. And that's really important to us to make sure like our payment journeys are rock solid and we handle those failures. Like you said, you have to expect them. So we have to make sure we can test for all those failure scenarios.
yeah, interesting. So it's almost like your own internal chaos testing, which is actually pretty critical, especially for what you're doing. Yeah. So,
Exactly.
Yeah, there was a question here. Brian Hunt had asked, did you guys consider using Red Panda? I believe that's the vectorized stuff, right? It's a different use case, right?
No, we didn't consider that. So Nats doesn't have at least once deliver semantics, as Brian said, but we're actually using a technology called Jetstream, which is built on top of Nats. So it is actually possible to build technologies on top of Nats, such as Nat streaming and now Jetstream, that does give you at least once delivery semantics. So yeah, that's actually what we're using. We're not using sort of basic Nats.
Yeah, you're doing it at a different level. So cool.
Yeah.
Well, cool. Thanks, Kevin. There are no other questions. Unless anybody has a last minute question, I'm happy to dive into anything here. But I think we covered everything that we had talked through. Anything else, Kevin?
I was trying to think. I think. Sorry?
No, go on, please.
I'm just trying to think of any other pointers I could give people. I would say it's really cool what Cockroach are doing in terms of the offerings you have of like what do you call it now, like the serverless product you're launching. Yeah. So that makes it sort of fairly easy for someone to sort of give Cockroach a try without even having to worry about spinning it up or anything. They can literally point themselves at one of your endpoints and dip their toe in the water with it. It's probably like a really good place to start for people.
Yeah. Well, thanks, Kevin. You just like you solved my end here, and like the marketing people are all going to be happy with me that I gave a going away like, hey, go try Cockroach. No, seriously, it is fairly simple to do, and I'm excited about serverless going multi-region eventually here as well. Like right now, it's single region. It's a beta right now. Like it works. It's pretty cool actually. You can just code against it. We're seeing some people actually. Like they're using CockroachDB dedicated, the cloud hosted version or self-hosted, but they're using that for like development, which I find interesting as well as a dev environment and that sort of thing. So there's a whole lot of interesting use cases of how serverless can simplify things for people. When it becomes multi-region, and I can't wait I'm going to talk to one of our engineering managers again later today about that. I can't wait how do you automate multi-region will be a really interesting challenge, right? Like another really great one. So.
Yeah, that is quite a challenge. So I think bringing all of this up seamlessly and all the bootstrapping problems you have, that's something that is sort of a fairly challenging problem to solve, amongst others.
There are still a lot of difficult challenges to solve in the software engineering world. There are a lot of really great teams that do it on. And I think, what you all do in there, Kevin, is truly phenomenal. I mean, the tech stack that you all run in, the challenges that you guys are trying to tackle are just, it's truly phenomenal. It's to me, if you want to solve cool stuff, y'all, I know Form3 is a great place to do it because y'all are kind of doing some interesting things. So
yeah, so if anyone's watching, they're interested, we're always looking for engineers. So like one of the things I really enjoy is that you just touched on, Jim, is like really sort of pushing the boundaries of what's possible. So if you'd have said to me like 2 years ago, we're going to be running across multiple cloud vendors in real time, processing high volume, I would have gone like, you're nuts. But it is possible. It is challenging, but it is possible. And I think we've got a really great bunch of engineers here, like pushing the limits. So if you're interested, then, head over to our careers page. We're always hiring.
Yeah, please do, y'all. So try serverless, head to the careers page at Form3. We covered it all, Kevin. We went through a whole lot of requests. It's great, dude. So seriously, Kevin, thank you for doing this. It's always enjoyable to talk to you. As a former practitioner, it's my curiosity is always comes through in these type of conversations. So thank you so much for doing this today.
Cool, no worries. Thanks for having me.
All right, y'all. Well, thanks everybody for joining us, taking your time out of your day.